At the end of the class, um, I told you today I may cover the generic classes and generic argument types, how to define a generic class and how to, what are the advantages of that one. But um, I have spoken with Murthy Garu in the last night, and then I got some feedback that most of you um, uh, has not studied about maps, hash maps as part of your data structure courses, but it's very, very important, okay, like to know about what is map, what are the advantages of map, how to use the map, and what are the different kinds of maps are available in Java, where to use and which type. That is very, very important information. I covered high level, but it seems since most of you does not have any hands-on experience on the maps, um, so I would like to repeat one more time on all the maps. Okay, like today, I will target to cover all the maps with including uh, corresponding examples, and then we'll go into the deeper dive of the concept of the map in Java. Okay. Uh, I just postponing uh, the class on the generics. Okay, like generic classes and type parameters. Okay, like I will be covering in the next class. If not in the next class, maybe after I cover the map reduce concept, again I will come back to the generic classes and generic types, and then I can give you a deeper dive on that. Today, um, let's see first of all what is map. Okay, like so, what is this map data type? Okay, like how it look like? What is the main purpose? How to define a map? What are different kinds of maps are available in Java? When to use which type? What are the advantages of each type? Okay, so these are the targets for today's class. Uh, uh, Even I explained in the introduction, most of this course is designed with a assumption all of you has some kind of experience in Java. Okay, like at least the assumption is okay, like you might be knowing about little bit about the Java. That's the reason I started directly about the class, and then I defined some methods, and then I executed the Java code and all the stuff. Uh, uh, if you guys still need some help in installing like Eclipse or any of the editors, okay, related to the Java, okay, like any of the Java development tools, let me know. Maybe I could also help you on that, okay, if it is really required. Otherwise, I will just assume that like you guys have a knowledge about, okay, like using the Eclipse and how to create a project, how to create a application, how to create a project inside the using Eclipse editor, and how to set your compiler paths and how to run a Java program and how to compile it, all that kind of stuff. Okay. I hope you all have that knowledge. Otherwise, like just let me know. I could start from over there as well. Um, I don't want to just go through the concept unless it is really required. Okay, like unless it is needed for you guys. Okay. First, let's start over. Okay, like a small class. Uh, I could say my map. Modifiers, we could keep the still public as what are the default it is. Since I want to execute this class, okay, like I'm just clicking on that public static void main. Okay, like so it will just add a stub to you, okay, like so that you could execute this class on its own. Okay. Since it's my map, okay, like I can go to the run and then like I can compile and I can run that one. Since it has the main method, otherwise you cannot able to execute it on its own. Otherwise you need to call the object of the class in some way to call your to call your application. Okay. So just before even we go into the deeper dive of the map, let's say first of all, what is a list, right? Yesterday already we gone through some of the examples related to the list. List type will allow you to store the values of the same type. Value might be a primitive data type or even any of the derived data type or any of the object of any of the class as well. But the advantage, the one of the advantages in using the list is you could access the element, a particular element based on its position. If I say like a list of 4, that will give me exactly what is the fourth element that has been inserted in the list. Okay, that is one of the advantages in having the list. But sometimes what would happen is it's very hard if the list has more number of elements. Okay, like so, it's very hard to know what position that value is really reside on. Okay, if I'm inserting into a random numbers like 100, 200, 250, 150, 200, 350, like that, it's very hard. I don't know when I inserted 250, whether it is third time, fourth time, or fifth time, or whatever it is. So in that case, if you want to see where exactly this value has been placed, you need to traverse the entire list. Okay. Uh, so look up if you want to look for any of the value, okay, inside the list. So you say that whether the list contains some value 250. So in that case, you need to traverse the entire list. So if any of the value matches with 250, then you would say that yes, this element is exists in this list. So the if you want to specify the lookup cost in using the linked list, you could say that order of n. If there are n elements in a list, so the worst case, okay, like will be you need to traverse the entire list, okay, like to get that one. Also, the list will allow you to insert even duplicate values. So sometimes the same value may exist uh, more than once. Okay, that's in that cases only people would use the list. There will be some other cases where you need to store only unique values, but you are looking in some cases where you don't want to traverse the entire list. So you are looking that your lookups would be much more faster way. So in that cases, one of the um, uh, useful collection available in Java is use the map. So map, what it does is it will store key value pairs. So enter the map. Of course, here the map means okay, just like a interface, but I'm just using the word like high level. It is a map. So map, what it does is like it will store key and then key values pair. Everything as a pair it will store. So map is a collection which will allow you to store in terms of the pairs. So the pair has a key and then value. So you could always look the entire values of the map by looking for a key. If you pass a particular key to the map, it will give you the corresponding value. And all the keys in a map will be stored in a binary tree format. I'm pretty sure, like, you know what is a binary tree, okay, right? As part of your data structures. So all the keys inside the map will be stored in the binary tree, and then it will, based on the key values. So whenever you pass the particular key, okay, like then your lookup will take much more shorter time. I think it's log n time. Okay. So the what is the cost to look for a particular key in a map is nothing but login. Okay. Login people would also like order of one as well. Okay, like, but it's frankly speaking, it should be order of log n. So the map is a collection where it will allow you to store a pairs of key value, key and then value, key and then value. Okay. So what we do is, let's take a small example of like how it stores the key value, how I retrieve a particular value by based on key. And sometimes what would happen is even you don't have the key value. Okay. If you have the key value, you pass the key value and then map will return you the corresponding value stored in that. Uh, one constraint in the map, whenever you try to insert a duplicate key, it will override the existing value. So suppose, for example, I already stored a key value 100, okay, key as 100, and then value as something else. Okay, like let's say a numeric word representation of. Okay, let's take a small example. Maybe that would be easy. Okay. I have a hash map, okay, like it is an integer, and I could say like it's just like a my map, okay, like a new hash map, and then integer. Everyone, you guys understand this statement? What I've written here? I just define a hash map. Okay. Um, by the way, here, what do you say? You can here also you could define just like a map. Sorry, it's not allowing. When we define a new class of the hash map, okay, like here we are specifying that what is the type of the key and what is the type of the value here. The key is the integer and value is just string. So that's what it indicates this angular brackets. So my hash map, now my map or hash map, it's storing the values, storing the key value pair of type integer key and string value. So what we could do is how to store just my hash map. Okay, you could say add. No. Here the put my hash map dot put. Let's add key of 100 and then value, since it is a string, I will give that word representation of this of the value. So I will say like 100. Okay, and two more. Okay, so now I added four key value pairs into the my hash map. So 100 is the key and a word representation of 100, 100 will be my value. And same thing even for 200. 200 is the key. This 200 will be the value. 300 will be the key. And then 300 in word representation is called value. 400 is the key. And then word representation of 400 is called value. So now my hash map has four values. Okay, 4 key value pairs. So I could use the hash map to retrieve a particular value based on the key. Let's try that. I could say just value of key 400. What I will do is my hash map dot get. I will pass the key value there. So if I pass the value 400, so for a given hash map, I pass the value, I pass the key as 400. So if I pass the key as 400, I'm expecting the return value should be that highlighted one, the word representation of the 400. Let's give a, let's execute this and then let's see that. See, value of key 400 equal to 400. The advantage of the map, it will not traverse all the entities, all the entries of the map. So whenever you pass some particular key, it will find out that where the 400 is and it will fetch the value immediately. In case, even if you define a linked list, okay, like so, you could add the similar values 100, 200, 300, 400 even to the linked list. But if you want to get retrieve as a particular value, okay, what it does is it will traverse the entire list until it hit the value. Whereas map, it will not traverse the entire. That is the main thing. That is the difference. So, and also in the linked list will allow you to access a particular element based on that position. So if you say like list of 4, that will give you the fourth element that you inserted into the list. But you don't know like really when you inserted this one. So whether you inserted first 100, 200, 300, 400, the application which is inserting all these values need to remember the order. Then only, okay, like you could retrieve it in less time using the linked list. But here, hash map, you need not remember an order of the data that how you inserted, but you just remember the key. If you remember the key, you get the value. That's why it's been defined as a key. This is the key for entire value object. Okay, so that's how you will get that one. Suppose by just for the validation purpose, what would happen if I pass the key which does not exist? Maybe let's make that 90. If I pass a key value which does not exist, let's see that what would happen. It will simply return the null because there is no value exists for that key. Okay. Another one. Okay, like let's say now 400, right? You got that 400 back, and now let's try to insert the value 400 again. Okay, like let's see what would happen. My hash map dot put 400 again, and here we just give as so now I changed the value. I added the keyword as new, and now we'll see that what would happen if I tried the same resource statement here. So if the key already exists, so it will override the existing value. Okay, like whatever the value is there previously, so that will be overwrite with the new value. If the key value exists. If the key is not exist, obviously it will try to add the key into that hash map. There are a lot of methods are available. Okay, like to find out that you could see that contains key. Okay, like you could see that whether this. So if the um, particular key exists in the map, then it will prompt you like this. Okay, like so. Okay. So here it would say that like the key, whatever thing that you could say that, okay, if it is contains. So you could execute and then you could say that like, so it say that given key value 400 exists in map. So before you put some key value in the map, okay, it's always advisable to see that whether it exists or not. But if you want to have the behavior of overwriting the value, okay, like you could overwrite that. You would say that yeah, this key is already exists in the map, and then it will do that one. So similarly, if you want to, there are a lot of methods are available. Okay, like one by one, you could see that one. There is a you could remove a particular key from the map by calling that.
Professor,
Yes, sir.
I have a small doubt here.
Okay.
Because when you are working the problem of word count, both key and value will be identical. So in such case, how to handle this? Will hash map doesn't work, or how do you make it happen? Because initially you have to accept the key value pairs and then you will count it, right?
For word map, that's true. Okay, like, but both are identical will always be happen. Okay, like, so I will explain that one whenever we are talking about the word map. Okay, like, for the
Sure.
same key value pair, what it happened. Okay, like, but,
Okay. Okay.
uh, I mean, here, when we are learning the map related things, if the same
Okay.
key exists, so your value will overreturn. That is only the concept.
Okay. Okay. Fine.
Okay, so I mean, to clear your doubt, in the word count, what we'll do is we will not see whether key value exists or not. So every word, okay, like we will send an entry like this, and value will always. I mean, I can show you that one. Uh, Suppose, for example, this is my new now. Let me define that. In case of the word count, okay, like normally what we'll do is we'll not name it as string. We'll say that string and then integer. So these two things will be reversed.
Yes, string and integer. You are right. Yes.
Yeah, string and integer. See, what would happen is uh, so if in a particular file, okay, like it's the same word, but there is a chances that it may repeat more than once, right? So that is the reason, okay, like if I'm giving that, okay, thank you. Now it's better. So value, I always be one, okay, like and then it will pass all this key value, okay, like I don't know, I'm getting a lot of questions. And then particular word, and then the value will always be one, and then we'll send that one. We always send as a key value pairs. Okay, like so. Here, I mean, frankly speaking, we don't put into any hash map like that. We send the key value pairs. Okay, like there won't be any map which will store all the things exactly like. So we'll send all these keywords like this. If the same word has been repeated, okay, like it will send the key value pair like this. If there is other word, okay, like different word, like that. I mean, I will go through that whenever we are talking about the word count in much more detailed way, but that's what it happens.
Right. I agree with that.
Here there are a lot of methods are available in the hash map. Okay, like remove is the one. Okay, like you could remove a particular key. Okay, like for example, here you could remove 200, and then after removing the 200, okay, like you could give a try. I mean, let's give a try before trying to remove that key. Okay, like so, and then try the same thing after remove the key. This is how you remove a particular key value pair from the map. So it's always key. Key is the input value, and it will return the output. Output as a value. Key is input for your map. So that is about the remove. Okay, like and let me see what else are really important. There is a key set. This is also sometimes people would use it. Okay, like so. This key set will return a set of all the keys. So it returns a set. Again, set is a collection, okay, like which will have all unique values, okay, like of same data type. Again, linked list will allow you duplicate values, but set will not allow you the duplicate values. So it will return all the key. It cannot be duplicated, right? Key always will be unique in the map. So that is the reason the key set will return a set of all the keys available in that map. So some this key set will be useful whenever you are traversing a hash map. Suppose I want to integer value from the list. I want to traverse the entire map. Okay. Uh, this key, my hash map that key set will give you the set of all the keys, which will be of type integer here, and the value of, sorry, here maybe I could select key only so that you guys will understand very well. So this key set has all the keys and of type integer. So what we'll do here is system dot out dot println value corresponding to key. Here you could say that a key so my hash map dot get of key. This one. Here I don't think we require that. Okay. Now you try to execute this program. This key set will help you out, okay, like to traverse the entire map, all the keys of the map. So first value corresponding to the key 400 is the new 400, 100, and then 300 because we removed the 200. So that is the reason. So now the hash map has 400, 100, and 300. You might be observing that like why did we got the 400 first? Okay, like we'll talk about that one. Okay, like this is how we are got the complete key set of the hash map, and then we travel, and then we got the corresponding value. Okay. Similarly, okay, like it also has API to get entry set Okay, like this entry set is nothing but it will give you in terms of the key value pair. Okay, uh, this is another way. Entry set means each entry in the map. It is nothing but key value. Again, you need to differentiate whether it is key and value, and then from there you can go that. So this is one of the methods. But most of the cases, people would use the key set because they would like to see what is the key value there, rather than having the key value there. And then once you got the key, you can get the value by calling the get method. And remove we already covered. And there is a method which will give you is empty. Okay, like which will give you that whether the hash map is empty or not. Other important thing is size. Okay, like this will give you how many key value pairs exist in the map. This is also uh, very much helpful in doing traversing the map, in doing some of the operations using the map. Total key value pairs exist in map. Uh, that would be my hash map of size. Size will give you exactly, but here in this case, our example, in our example, I think it will give you the size as 3 because we have only 3 elements in the map. So the total key value pairs exist in map are 3. Okay, so here the value you could see everything. So that is about the size. Okay. What else? They are the very important one. Put remove contains key. In contains key, we already looked at one entry set. Clear. The clear will delete everything in the map. Okay, like so um, if you want to know whether there are any elements exist in the map, okay, like if the map is not empty, then you can say clear, it will empty the entire map. Compute, that's different thing altogether. Contains value is also there, like similar to the contains key. But contains value, what it does is it will traverse the entire map. Okay, like if you want to see the contains value, the value can be duplicated. The key will not be duplicated. All the keys in a map are unique, but the value might duplicate it as well. Okay. Uh, Size clear. I put that. For each get class, hash code, merge. You could combine multiple maps together using the merge option. Okay, like you have one map together, another map, both types are same. You could merge the two maps together and make it a single map. Remove, replace. Replace is also good. Replace or put will do the same thing. If you give the replace, the key exists, it will go and replace the value. That's what it does. It's same as calling the put for a duplicate key. That's it. That's all about map. Nothing else. Maybe I could say at the end, it's clear and all all the size function exist in map after calling clear. So initially I got some map elements and total key value pairs exist in map at 3. Then after that we call the clear, and then when you look for the size of the map after calling the clear, then it will be 0. So any questions, or is it clear everyone how to use a map? What is the advantages of using a map?
Uh, Professor, the concept is clear, but in what context we use hash map? What kind of problems we use this?
Uh, Wherever, okay, like you want to retrieve a particular value based on key, okay, like map will be used, map or hash map,
That is for equality selection criteria, right?
equality
Like
selection criteria. Yeah.
from symbol table, searching for something,
Yes.
the equality
Most of the
selection
cases,
kind.
most of the cases, it's lookup table, lookup
Yeah,
kind of a
lookup
thing.
table, right?
Lookup table or mappings, like one-to-one mapping. If there is a one-to-one mapping exists for any of the key value layer, you could obviously use the hash map.
Okay.
Even sometimes what would happen is uh, linked list will just store the value, right? Nothing else.
Right.
So people, what they do is, suppose I want to store 100, 200, 300, 400. That's it, nothing else. I don't have any corresponding value for that. Um, this is this is also, I have only the key value exists, but I want to store only the unique values or unique keys or unique set of that one. So people use like just like 100 and 100, and then they define it as an integer like this. If you have the same thing, store the same value as both key and value. So in that way, while um, storing itself, it will make sure that it has all the unique values. Okay, but not much advantages. But you could also, instead of storing the same key value pair, okay, like you could also store it in terms of set. If you define a set, if you add all the values, and if any value is duplicated, obviously set will ignore that. Okay, like that kind of a thing. Here, I mean, here, my point is key and value need not be a different data types. It may be a same type as well. Okay. Suppose like 100 to, you could say like maybe I'm storing the reminders. Remainder when you divide by 10. Okay, like so 100 when you divide it by 10, I'm getting the remainder at 0. So you could store all the values like that. Anything. It can be integer to integer, integer to string, object to object. Okay, like that kind of a stuff. Okay. This is one kind of a uh, map-based collection in Java. Okay, which is nothing but hash map. So here in hash map, um, internally when it's storing into the map, okay, in terms of the key value pairs, it will always store based on hash code of key value. So here the key is 100, 200, 300, and 400, right? So inside, anyway, since it is a map, it will store in terms of the binary tree. And again, in the binary tree, the value of the nodes it will be hash code of these key values. Okay, that's why when we traverse the map, okay, when we traverse the map, the first value I got is 400 because the hash code of 400 might be uh, uh, might come first when you compare the hash codes of 100 and 300. So when you compute the hash codes for all the keys, like 400, 100, and 300, so if you order based on these hash codes, the 400 will come first, and then 100, and then 300. That's why when I traverse the map based on the key sets, I got the first 400. But if you want to restrict the order on which you inserted into the map, okay, uh, not like very much advantages on that, but sometimes people would prefer that. I ordered uh, when your key is something like timestamp, okay, like year, date, month, like that, some string. So you always prefer uh, to be in the same order, what order that you inserted the key value pairs into the map. Okay. So in that kind of a scenarios, okay, people will not use hash map. Instead of hash map, um, they use a linked hash map. Um, what I will do is I will copy the entire the program and make a new one. And this one is not a hash map, and this one would be linked to the hash map. So instead of hash map, I defined as a linked hash map now. Same thing, my linked hash map. Now I inserted 100, 200, 300, and 400. Just for our understanding, let's not remove that 200, okay? And then let's see that what would happen to the order. Still, I got the same. Sorry, since it's a key set, it's not a key set. We need to do the entry set. So entry will have always key value paired. You could say like get key and then entry dot get value. Uh, so now you see that 100, 200, 300, and then 400. It will be the same order, which order that will be added into that one. I think I got a mistake in understanding it. But let's remove the entry set and try for key set as well. Let's see that one what would happen. I got 100, 200, 300, and 400. So entry set or key set is giving the same values anyway. Um, when you use the linked hash map, you get the same order. So instead of computing the hash code, it will try to add the same value itself uh, when you use the linked hash map. Uh, it, Internally, it will store in terms of the binary tree only. But while doing that binary tree, okay, like the values for the nodes, okay, will be passed as exact keys. Okay, that is the reason you get the same thing. Okay, like uh, this is the linked hash map. But when you run hash map here, there is no. It depends on the hash code of the keys. Okay, like so. That is the reason first we got like 100. When I run this, my map, you will see that first year I got like 400, and then 100, and then 300. So the order is based on the hash codes. When you use the linked hash map, it uses the same order of how you inserted data into the linked hash map. But the rest of the methods are the same. All the methods which are accessible from hash map, okay, like will also be accessible from linked hash map. There won't be any difference, and there won't be any additional thing as well. Pretty much same method we could use it. Um, yeah. So typically people when they try to pass a date timestamp, okay, like year 2017, July, and data 17. And I'm passing each day, okay, like every day that I'm adding a new entry into the map, sometimes they would try to see the same order, okay, like how they inserted all the dates into the map. They would like to see the same order when they traverse the entire map. So in that cases, okay, the people would use linked hash map. Okay. But if you never ever uh, get a requirement to traverse all the entries of the map, then it doesn't then it does not matter. You could use any of the maps, hash map, linked hash map, or even the free map. Next one, uh, okay. Here I will do. I want to do one more thing. Okay, like quickly. Uh, my linked hash map dot put, because everything, if you observe that one, it will be the same order. Okay, like I don't want to have that one, so let's have that here. Um, let's say 250. Okay. So after 400, I added the 250 here. Let's see that which order that it should come in the linked hash map. So 100, 200, 300, 400. Then after that only 250 is displaying. Okay. So when it builds the binary tree, so it always gives which position that you added, like if it is added 0, 1, 2, 3, 4, 5, like that, that value will be used in the nodes, okay, like while um, sorting out all the elements. Okay. But so this is what like advantages of the linked hash map over hash map. Okay. Third type, third type of the map, okay, like it's called tree map. Okay. There is a third type of the map. Okay. I will copy the same thing. Another thing I'm defining the class here. Okay. So now we define as a tree map. Again, the types of key value pairs are the same, integer and then string. I inserted the same keys 100, 200, 300, 400, 250, and word representation of the same. So now when you traverse the map using any of the methods, using the entry set or using the key set, okay, like so, what would happen is uh, even though you inserted this order 100, 200, 300, 400, 250, but it will try to sort out the key values and then displays in the sorting order. That is the advantage of the tree map. Uh, Try to execute this. Now you see that 100, 200, and after 200, I got 250. Even though 250 added at the end. So in the tree map, always the keys will be sorted out. The keys will be stored in their ascending order. So that is the reason whenever I traverse the entire list, so I always get the 250. So you put all the dates like keys in your hash map. Okay, like but you want to traverse the list. Okay, like based on the dates or based on the values of the date. Okay, like then you use the tree map. So that is the advantage of having the tree map. Here, whatever may be the order that you inserted all the values in the map, but you want to store in the ascending order of the keys, then go for the tree map. Again, even a tree map also, whenever there is need to traverse all the elements of the map, then only you need to see that whether tree map versus linked hash map would make sense. Otherwise, defaultly you can use any of them. Most of the cases, people would use hash map. Okay, like yeah, that is the first one that will come to their mind and then they use it. But when compared to the hash map, tree map, uh, tree map would be the better way. Okay, like so even if you want to traverse the entire map, it always gives you the ascending order, and then obviously like you know that um, while debugging or anything like that, if the map has 2000 elements, then at least you could see that where it was broken and where it has some keys missing, something is happening. So it's helpful for debugging if you use a tree map. So assumption is not assumption. The functionality of the tree map is okay. Like all the keys will be stored as per their sorting order, their per ascending order. That is the advantage of the tree map. Again, if you see the functionality, it looks like the similar thing. Linked list versus what do you call it? Array list, a linked list, that kind of a thing. Okay, like so, linked list will give you the same order of how the values will be added into that one. Okay, like a similar way. Especially in the sets. Okay, like I know I've not covered much of the sets here, but let me show you. I mean, before even I touch the sets, is it clear, everyone? Okay, like map. What is map? What is key value pair? What are the advantages in storing your data in terms of the key value pair? How to access a value based on the key? What is hash map? What is linked hash map? What is tree map? What are the differences between these three? Okay. So these are the things that we covered on today. JNTU Vijayanagara. Uh, yes, Mena, what is your question? I'm unmuting you. You could talk as well. How three maps are giving different hash code for same value? How three maps are giving different hash codes for same value? For same key, 100 and 200. No. Uh, I Hash code will be calculated only when you use a hash map. Um, when you use a tree map, I don't think it uses the hash code at all. Even in the linked hash map also, it won't use the hash code. Hash code will be used only in the hash map. Whenever you use the hash map, then only it uses the hash code. That's why it's named as a hash map. When you use the tree map, it uses the physical value. Okay, or else it not exact. If it is an integer, it uses value. If it is a string, okay, like it will sort out based on the strings. Okay, like based on the string value. If it is an object, okay, like um, uh, it will give you that order of two string values. Okay, that is the difference. If it is a primitive data type, it uses the exact value. But if it is a non-primitive data type, if it is an object of any class, then it uses the value of toString method. Okay, like as its value of the key, and then it will sort out based on that. Okay, so is it clear now? Murthy garu, shall I give you some more thing, or is it clear? I think this would be um, enough. Okay, like to wherever they want to use maps. Okay, like I mean deeper dive of this is not, I don't think it's really required anymore. I think this would be enough. Um, I do have, now we will say the set. Okay, like set also has three types: hash set, linked hash set, tree set. Okay. Concept is pretty much similar. Okay, like hash link versus tree. Okay, hash versus linked versus tree. The concept is same. Whether it's a hash sets or whether it's a hash maps. Okay. Set is also a collection where it will allow you to store values of a particular data type. But the advantage of using sets is while storing itself, it will try to remove the duplicates. And again, it will not be a just key value pairs. Okay, like it will be only for values. Okay, it's not a, again to retrieve a value from a set requires traverse of the entire set. Okay, so it will not be again. It will not give you the order of one or order of log n like that, but it will give you always order of n. Okay, like if you are looking a particular element in a given set, whether it exists or not, it will take order of n time. Okay, so that is one uh, fixed of set. Set versus array list or linked list. Okay, like because linked list will allow you duplicate values, set will not allow you to have a duplicate value. That is the only difference. Uh, for example, I will define a hash set here. I know I don't have much time here. That is the reason I'm showing the code. Okay, like so instead of typing everything. So I added 100, 200, 400, 100, 100, 100 like this. So even though I added the same elements three times here, but if I get the size, hash set size, I'll get only the three because this 100 is already exist in the key, exist in the set. So it will not be added again. Even this 100 is already exist in the set, so it will not be added again. So my set will have only three elements, 100, 200, 400. So this hash set size will be 3. You could traverse the elements of a set like that directly inside the for loop. You could define element colon my hash set and everything. Next type is called like linked hash set. Even in the linked hash set, it will not allow you the duplicates. But when you are traversing the linked hash set, you get the same order how you added the elements into the set. Okay. Third type of set is called like a tree set. Tree set also will not allow you the duplicates, but the values you stored in the tree set will be stored in their ascending order. Okay. When you try to traverse the element of a tree set, you will get all the elements in their sorting order. Let's try to execute this code. And then we can see that one by one by one. So initially hash set size is 3. Even though I added 6 elements here, out of 6, 3 elements are duplicated. That is the reason set will not allow you to allow the duplicates. So your hash set size is 3. And when you try to traverse the hash set, you get like 400, 100, and then 200. So for hash set, it will calculate the hash code corresponding to the values that you passed. It will be stored in that order. So hash code of 400 will come first when you try to order their hash codes. So 400 of hash code will come first, and then after that 100, after that 200, like. And the same thing if you pass it as a linked hash set. So initially you added 200, that's why you got 200 here. And after that you added 400, you got the 400. It's 100, 100, 100, 100 like that. So all are duplicate elements, so you get only 100 max. So the linked hash set will give you in the same order how you added the elements into the linked hash set. And third type is tree set. Even though you added 200 first, 200, 400, and then 100, when you try to traverse the traverse the set, it will give you 100 first, because when you order by the value, okay, like 100 will come first, and then 200, and then 400, and then 1000. In the tree set, there is um, one interesting thing. Since it is an integer, 100 will come first, then 200, 400, and then 1000. Okay, like here I will show you a small thing. Define a tree set of type string. So now I change from integer to the string, and all these values I just add the quotes. When you add the quotes, it became a string, right? But still the value would be uh, like 200, 100, 100 like that. But I just passed it as a string instead of integer. Let's see what would happen. And at the end, remember here I passed as 1000. Okay. Everything is same. Okay, here it's about integer. The type of the set elements, which is a string. Okay. Now you try to execute this program. Did you see that order? First I got 100. After that I got 1000. Then 200. Then 400. This is type of a thing is called like a alphanumeric sorting. Okay, like so. It's it always gives you, when you try to order these elements, okay, like when stored in it as a characters or in a string, you will get that order. So first you get 100, and then still the 1000, 200, and then 400. It is how the strings would be sorted out. Okay, like when you try to give them as ascending order. That's what I thought about. There is a difference between when we add it as an integer, that's a value. When it is a string, okay, like it will go to that. So there's like there is a term. I forgot that. Any text values, any string values, if you try to sort out, okay, like it will come like this only. And if there is a 10,000, you get first 100, 10,000, 10,000, and after that 200, 400, like that. Yeah, it's called like a sorted by the ASCII codes or something like that. Any further questions? We do have 5 more minutes. And then we'll go a much deeper dive. Okay, like we'll try to cover everything related to the map reduce, Java map reduce. Okay, we'll see what is map, what is reduce, how we'll call map reduce functions, and how it will be useful, all that kind of stuff in the next class, in the coming Tuesday. Any questions on today's